this is going over writing a number as a product of their prime factors using prime factor decomposition. Now, to do this, you need to know your prime numbers. And I've written these out all the way up to 100, all the prime numbers there. Now, you need to know these, but in most of the time, you need to know probably the first few, I'd say. So up to, say, here, about there. You need to know those ones there. Now, I'm going to jump straight into an example with these. And I've got some steps to go over to explain how it's done. So, I've got a question, write 18 as a product of its prime factors. Now, first thing you want to do there, well, we'll start with 18, but you want to list the first few prime numbers. List the first few prime numbers. This is because you're going to be using them. So just write them down somewhere so you've got them to hand. 2, 3, 5, 7. I'm going to 11. Let's just leave it there for now. Then once you've done that, what you want to do is you want to divide this number here by the lowest prime that goes into it. So what you do is you look at your list there, 2, 3, 5, 7, 11, and look for the lowest number out of those that goes into it. So hopefully you can see that 2 goes into 18. So what you're going to do, we do what we call a prime factors tree, like that, and I'm going to put 2 there because it's been divided by it. So 18 divided by 2 gives me 9. All right, that's the first step or second step. Once you've done that, circle the prime to show it can't be divided more, because a prime only has factors of 1 and itself. So I'm going to circle that to indicate it's done. Now, once you've done that, divide the answer from step 2 by the lowest prime that goes into it, and then circle the prime number again. So this answer here is now going to be divided by the lowest prime that goes into it. So you start again at 2, if you can divide it by 2. Now, that doesn't go. So let's look at 3. Yes, 3 goes into that. So divide it by 3. And 9 divided by 3 is also 3. So what we're going to do is circle that prime we divided by. Now, what you do is you repeat that process with your answer each time until you're left with 2 primes at the end. Now, we've got a prime there and we've got a prime there. So we've got 2 prime numbers at the end. So that has been fully, put into its prime factors. So now to finish that off, you will now write it with the primes being multiplied together. So it will be something like this. 18 equals 2 times by 3 times by 3. And you can write it as index form. So it depends on the question. So that will be 2 times by 3 squared. And that will be this written as a product of its prime factors, so 18. Now I've got a second example I'm going to do for you now. So it's write 45 as a product of its prime factors. So once again, we're starting with 45. And first step up here was list the first few prime numbers. So 2, 3, 5, 7, 11. Now I'm going to start off, divide it by the lowest prime that goes into it. 2 doesn't go into 45. 3, that goes into 45. Now it doesn't necessarily have to be the lowest one. I prefer to work that way. You can do other ones if they go into it, because 5 also goes into 45. But I'm going to do it with 3. So 45, so you write it out into your tree. So that is 45 divided by 3 is 15. Now that's a prime number, so we have to circle it. So we know we've got a prime number there. Now, once we've got that, 15, we've got this now. So we repeat that process, look for the lowest prime that goes into it. So 2 doesn't, 3 goes into it. So I've got 3 there, and 15 divided by 3 is 5. So 3 is a prime number, because we know. And then we've got 5, and we look, that's actually a prime as well. So we circle that. So we write this out now as a product of its prime factors. So we'll do 45 equals 3 times 3 times 5. Or you could write it as index form, depending on the question, which will be 3 squared times 5. What's important, what you can do to check also at the end, I should have mentioned this above, is you can multiply them together, see if it works. So 3 times 3 is 9, 9 times 5 is 45. So it does work. Same with that one. 2 times 3 is 6, 6 times 3 is 18. So that works. Now I've got 2 down here for you to give a go. So do press pause, give it a go. So we've got 36 and 200. And then I'll go over those in a moment. Alright, so let's look at 36 then. So I'm working with 36. We got 2, 3, 5, 7, 11. So writing those first few primes. Okay, number that goes into 36, 2 fits. So I've got 2 there and 18. 36 divided by 2 is 18. And then that's not prime, so looking at my list again, the lowest prime that goes into it is 2 again. So I can reuse it. So that's 2, 18 divided by 2 is 9. Okay, I'll just shift this a little bit. So we got 2 as our prime. Then we have 9. So lowest prime that goes into 9, 2, 3. 3 is the lowest one. So 3 there. 9 divided by 3 is also 3. So we've got our prime factors there. So 3 and 3. And then we can write out our answer. 36 equals 2 times by 2 times by 3 times by 3, or in index form. Like I said, depends what the question's asking for. 2 squared times 3 squared. Okay, so that's that one. Then we look at this one here, 200 as a product of its prime factors. So start with 200, write out our prime numbers. So 2, 3, 5, 7, 11, so we remember those. Lowest one that goes into 200 is 2. It's always nice if it starts with 2. So we've got that. So 100 divided by 2, 200 divided by 2 is 100. So we've got a prime there. Now look at 100, lowest prime that goes into it is 2. So again, 100 divided by 2 this time is 50. So we've got that signal that we've got another prime. Now 50, the lowest prime that goes into that is actually 2 again. So we can repeat the same prime numbers. So 50 divided by 2 is 25. So we've got that. And then next one, we've got 25 there. The lowest prime that goes into it, if we have a look, 2 doesn't go into it, 3 doesn't, it's 5 now. So 5 and 25 divided by 5 is also 5. So 2 prime numbers, 1, 2 to finish off. So we can now write our answer of 200 equals 2 times by 2 times by 2 times by 5 times by 5, or depending on the question in index form, it will be 2 cubed multiplied by 5 squared. And that is writing your numbers, products of their prime factors with prime factor decomposition.